Okay, so now we know what a function is, we know what a graph is. We can do what we call the vertical line test. So some of you probably heard this before. It's a pretty common test that people use. So if it is possible for a vertical line to cross a graph more than once, then the graph is not the graph of a function. So what I mean by that is that, say I got this down here, this is an equation I'm looking at that makes a circle. It's a little hard to see this line, but if I can draw at least one line, it just has to be only one line and it passes that graph in two spots. So as we see here, I draw this vertical line and I cross the graph of my equation in two places. Once that happens, we know that this cannot be a function, and there's a very good reason why. So if you remember, the point of a function is that one input should only produce one output. Well, this point here, this is where I had an x of 1. So I put 1 into this equation, or this relation, that's another name for equation. I put that in, and what came out was 2.828. Well, here's the problem. I also took this same number, and when I plugged it in, got this as well. So also, if x is 1, y can also be negative 2.828. So we have a problem here that one x is producing two y's. So, like I said, the graph of this circular relation does not pass the vertical line test, because when the line x equals 1, or goes through x equals 1, it crosses my graph in two places, meaning I had two outputs. This means an output of 1, or x equals 1, produce two outputs, meaning this can no longer be a function. Oops, sorry, I got a button on this thing. It keeps moving stuff. So we want to determine whether the following is the graph of a function. So this is just sort of an example. Is this first one here is that we see that if I draw, it just has to only be one line. It has to only happen one time. That's all we need. So I draw one vertical line here. I see that I cross 1, 2, 3 times. This is not a function. If I look at this one over here, I cross once, I cross once, I cross once, I cross once, and just pretend these are perfectly vertical. I cross once, only once, only once, only once. So there is no place that I can draw a vertical line that crosses more than one time. That would have to be a function. And the last one, this lightning bolt. Just to point this out, if I crossed out here, I hit here and I only cross one place. But the problem is that there is at least a place where I cross two times. Or in this case, I can cross it. Let me see, was that 1, 2, 3, 4, 5 times? So like I said, if I can draw a vertical line one time and it crosses that graph more than once, we know it's no longer a function. So graphs that do not represent functions are still graphs of relations. There are equations that make all of these graphs. It's just not all of those equations are going to be functions. So for your last few problems, is we're just doing the vertical line test. So just to see, decide if these are functions or not functions using the vertical line test. Once again, these ones are a little tricky. There's one spot on that's going to be a trick. See if you can catch it. And then this one here is, this is not a vertical line test, but this is a last problem, sort of more of an application problem. Just seeing if we can read the graph. All right. So for A, we're going to make all those lines. Like I said, if I do this, I cross this red line, my graph of my function once, cross it once, cross it once, cross it once. So that one wasn't very vertical. I can keep drawing lines and I'm only crossing once. This is the graph of a function. Write that in a darker color. So this is a function. The other one, you probably already kind of figured this out, right? I just need to happen one time. So if I cross out here, I only cross once. If I cross here, I only cross once. For this one in the center, that's my problem. I'm crossing 3 times. So this is not a function. Also, what we'd say is that this passes the vertical line test. This one over here we would say does not pass the vertical line test. So C and D, like I said, there's a little trick to it, and it has to do with some points here. So for C, we see all along here, I'm passing the vertical line test. All along here, I'm passing the vertical line test. What we got to be concerned with is right here in the center. So this is an open point, and this is a closed point. This means if I draw a line right through here, there we go. There is no point here for me to go through. Here, there is a point. That was supposed to be no point here, not point here. No point here. The point is here. So that means that this only crosses 1 point. So because I crossed only 1 point, I only crossed at most 1 time, I passed the vertical line test. This is a function. The other one, there's a slight problem. We have that same thing here. As I go along this part, I'm only crossing 1 time. But here, there's a point. There's also a point here. So what we have here is we got a point that x is 0, y is 0, and a point here where x is 0, y is -2. So automatically we're seeing a problem here because we have one x value, but we're getting 2 different y values. If I pass through here, I pass this point and I pass this point, I pass through 2 points. So this crosses 2 points. So simply here, we have this was an open point. There's not actually a point there, it's an empty space. When you have a closed point, it's not an empty space, there is something there. So for this one, I passed through, there was nothing here to go through. This I hit. This one I hit here and here. So this one is not a function. And our last one, 15, technically it's a standalone problem, but we'll just put it in here right on the end. The following graph represents the ages of an individual and their target heart rate. So we see that this is a function. We want to know what is the target heart rate for the 46-year-old. That is, we want to find f of 46. So like we said, we know that fx represents a y. And we know in here that's our x. So what we're saying here is that x is going to be 46, which is roughly about here. So if x is 46, so this one, if you didn't get it exactly, that's fine. We're kind of doing an estimate here. I cross about here. So what that means is that the y that comes out, let me go get a straight line. It's not working super great. There we go. So we hit that point. We're hitting roughly here. So this is 100, 110, 120, 130, 140. So I'm between 130 and 140. I might say that's 132. So what we have here is that f of 46 is 132. This means a 46-year-old has, represents the age of an individual, should have, this is what they should have. They should have a heart rate. So it's an approximately, but as of approximately 132. And if you look here, the target heartbeat is telling you is beats per minute. We're going to write BMP, beats per minute. Let's write this again, PBM, beats per minute. This part, what is the target heart rate for a 72-year-old? We're asking that same question again, except instead of F of 46, it's F of 72. Because this is my ages are X's. So if we try to find out where 72 is, roughly here, it looks like we get about a heart rate of 110 beats per minute.